Good morning, good afternoon, wherever you are. My name is Srinath, and I'll be taking you through unpacking Gen AI, making sense of everything that's happening in the world. Thank you for attending this webinar with Altis Consulting. Just in terms of some housekeeping rules, so we'll please continue, engage with us, ask questions. What we'll do is put your questions in the chat. We'll actually go through the presentation, and then we'll address all possible questions at the end. So in terms of, I think if you look at GPT-4 and Gen AI in general, I think there's been a lot of talk ever since in 2023, OpenAI came up with GPT-4. I think every corner of the business world, every industry that you go to, everybody's talking about Gen AI, right? And in terms of, a lot of people ask me questions in terms of where did this suddenly come from, right? Was it always there? There was always AI, machine learning, data science before that in some format. So what actually led to the pivotal moment in 2023? And when all of this came together, and it seems to have kind of taken over the world, and what are the implications for everybody going into the future, right? So I think part of it, as I try and explain how this whole thing has evolved, I think it makes sense to talk a bit about my experience, because I've kind of seen this over the last 17 years as data science has evolved from where it was to what it is today, right? So I got into data science like really early. I got into data science when it was or machine learning or AI, when it was not as glamorous as it is today. Actually, 17 years ago, we used to call it statistical modeling, right? And that used to be used to call it advanced analytics, where we used to do, very simple regression type problems to try and predict churn and some of the very simple equations, right? So obviously, there's been a lot of action through the years. And what we'll kind of do is, as we go through this, we'll talk about introduction to Gen AI. What does it actually mean? How does it actually work? In terms of the how deep I'll go, so I'll probably this particular webinar, we'll keep it at probably level 1 and a bit of level 2, right? There's obviously a lot of very detailed technical knowledge that's actually required to do something like this, but that involves a lot of very complex math and things like that. So for the purposes of this general audience, we'll keep it at kind of level 2. We'll try and understand in terms of use cases, what does it mean now that we've had all the big organizations, Google, Meta, everybody's coming with their own large language models. What are the implications, and what are the challenges going to be? So that's broadly the construct of how we'll do this. Look, I think 2023, when all of this came together, it was actually Gen AI is actually not a new concept, right? It has been, I think a lot of people on this call might be surprised that it has been around in various forms from about 2006. And we've been actively engaging in Gen AI, while we kind of, move along with our daily life, right? And 2006 is when kind of Google Translate started. And if you actually look at Google Translate, it's a lot of the fundamental concepts of translating, say, because I'm Tamil, so Tamil to English or any other language, there's a lot of what we call a generative large language model concepts actually working behind the scenes, right? Admittedly, it's not as complex as GPT-4, but there's the fundamentals were in place. They were actually real-time users of what Gen AI used to do, right? In about 2011, we started working with Siri, and I think again that's a good example of of engaging with like a large language model or Gen AI, where you can ask Siri to call certain people, you can ask it to put alarms, and it'll actually engage with you, right? So that's again and not as complex as some of what exists today, but that's been there since 2011. We've been engaging with it, right? And also in terms of when you actually go into Google and try to search for something, it'll give you a lot of recommendations based on when you say what is the capital of, it'll give you options, and there's a lot of logic actually sitting behind the scenes to be able to say that, why should capital of Ireland should come above capital of Wales and things like that, right? So look, Gen AI is not a new concept. I think there's certain advances in technology and certain maturity that it reached in 2023 that made it the force that it is today. But it's merely an extension of what has been happening for so long, right? So that's in terms of the how Gen AI essentially got started. So what exactly is Gen AI, right? How does it, what is the difference between Gen AI and machine learning? How is it different from artificial intelligence in general? What is deep learning? So I think it's important to kind of clarify some of how all of this kind of fit together, because what I've seen is a lot of people are sometimes synonymously use some of these, right? And I think it's important to clarify that all of them are related, but not exactly the same, right? So AI, right? AI is, think of AI like a branch, right? So think of it like physics, for example. So it's broadly a branch. It's an umbrella term. It's an entire area or subject that talks about specifically development of computer systems that can mimic, what humans do, right? Typically tasks that need human intelligence and what computer systems that can mimic that. That's broadly the field or subject of AI, right? So inside that, you have what is called as machine learning. So machine learning is like a subset of AI in general, and machine learning deals with anything that trains a particular model from input data, right? So it's a particular subfield where, in order to get a certain output, you have input data to get a certain outcome. You train a machine with that input data, and that gives you a kind of an output, right? So that's machine learning in general. So that's where the learning bit comes in. It's a machine that is essentially learning, right? So in order for it to learn, obviously you need to feed it, whatever data is available, and we'll talk about some of that, right? So machine learning broadly, again, are of two types. So there's supervised machine learning and there's unsupervised machine learning, right? So supervised machine learning contain what are called as tags, right? So tags could be a name, it could be a type. And if I have to take a particular example, right? So let's assume a restaurant example where you have, let's say, for a particular restaurant, you have a lot of transactions where you have the bill amount, and let's say you have the tip amount for the particular transaction, right? So if you have to predict using the historical data, which is bill amount, and how much somebody is tipping, the tip amount, what will that look, how can we predict what it look for future transactions? That is an example of kind of supervised ML, right? There's a model, there's a prediction. The prediction is compared to actuals, and there's constant self-learning that is happening to keep on improving the model based on specific tags or attributes. Unsupervised machine learning is when it's kind of exposed to unstructured data in general, right? So there's no tags. There's not, there's what you're trying to essentially, your output is not necessarily linked to some of your input variables and things like that, right? And we'll talk through some examples of, and let me take a particular example, right? So let's if we have a particular organization and you have, let's say, on one axis you have like time, the number of years, and on the other axis you have, for example, the salaries of a particular individual, right, or particular individuals. And then if you want to figure out using that data, saying that who is on which of these people, who's you can see their salary across time, who are on like a fast track pathway, right? If you want to do things like that, it typically does things like clustering, try and bring together people of similar categories together. So that's an example of kind of unsupervised ML, right? So, and there's, so both of these are fairly important based on the type of the problem. Sometimes you use supervised ML, and other times you use unsupervised ML. Deep learning is again like a subcategory of machine learning. And what happened, when why we actually need deep learning is when the problems became like really large, it required a lot of computations, permutations, and combinations. It actually we started using something called as artificial neural networks, right? So artificial neural networks are the concept came from our brain, right? So we looked at what is there in our brain and how it works. And artificial neural networks, which have neurons or nodes, are typically large constructs that is used. We can process much more data than traditional machine learning, right? So when you want to go past or try to solve problems that require a large amount of data to process and come up with certain observations, that's when deep learning came into play. So deep learning again was a very pivotal moment because it gave the ability to kind of scale up the size of the problem or the size of the machine learning or artificial intelligence problem, right? So that's again like a very pivotal moment. And then if you look at machine learning in general or even deep learning, you typically have like two types. So you have what is called as discriminative and what is called as generative, right? So discriminative is when you're in. Again, let's take examples, right? So it's a method of clustering or classification, where and if you take an example of images as your input, right, and you based on a large data that it's trained on. So at the end of it, the output will be, if you provide, let's say, a image of a dog, it'll be able to classify it as a dog or not a dog, for example, right? So any of these models that have broadly like discrete values as the output, or clusters, things like that, are what is called as discriminative models, right? And generative, where we start getting into our kind of our core topic, is when instead of actually being able to discriminate, you generate new content, right? So there's similar thing. You have large input data. You have a lot of training that is actually done, but the output of it is not necessarily discrete. It's generation of new content. That new content can be in the form of images. It can be in the form of language like text. It can be in the form of code. There's so many different options, right? So that's broadly the whole construct, right? So how it goes from AI to machine learning to deep learning to generative AI, which is like a subset of deep learning that is generative, obviously, right? As the name says. Yes, Gen AI. So if you look at what we've spoken about so far, and if you try and kind of what really happened to Gen AI to make it that pivotal moment in 2023 when GPT-4 came and everything started coming together, it's all based on what is called as the foundation model, right? So previously, if you look at you're typically using your supervised or unsupervised data, you have labeled data, data with labels, and then you have training code that typically gives outputs, right? But when you start moving into generative AI, so you have like training code, you have labeled data, a small portion of labeled data. It's still significantly unlabeled data, but sometimes a bit of labeled data helps in certain examples to kind of have the model learn something upfront so that it can solve some of these problems better, right? So there's a significant portion of unlabeled data. There's some labeled data, training code, and that goes into what is called as a foundation model, and then the output of it is obviously generates new content, right? So there's text generation, there's code generation, there's image generation, et cetera. And if you look at how it has kind of evolved, and you might have noticed this earlier. So images, I think for about maybe at least I would say 8 to 9 years, processing images has been easier, right? So AI was able to process images. So for example, if you have Google Photos, for example, I think for many years they've had the ability to kind of recognize objects, recognize faces, and all of that up front, right? But I think so the significant maturity improvement happened in the ability for text generation and ability to understand and structure language better, right? Because obviously language is a lot of what we do every day. So there's multiple languages. There's a lot of permutations and combinations. So I think that was one of the key things that kind of a lot of big organizations cracked the code on, and be able to say that now we really are able to generate more languages and things like that, and generate downstream, right? So that's again a very pivotal moment that kind of helped bring all of this together. So getting into the detail, right? So what is actually behind the scenes is something called as the transformer architecture. So transformer architecture is something that is essentially a type of neural network architecture. It's a type of neural network architecture that's been around for I think about at least 6 to 7 years. It replaced the previous neural network kind of architectures. And so think of it this way, right? So if you look at any neural network, right? The neural networks typically think of it as certain input variables. You have certain output variables, and you have multiple hidden layers in between, right? So multiple hidden layers in between, and each of these are nodes, right? So you have input nodes, you have output nodes, and based on the extent of the problem, on the complexity of the problem, you could have 1 to 100, 200 layers in between that is kind of trying to take your specific problem and try to generalize that problem and then try to solve for it, right? So that's what it does. And given this specifically about human language, right? I think there's a lot of there's a lot of technical detail behind some of this, but I'll try and explain some of how it actually all of this comes together. Let's take a sentence, right? Let's say that the chicken walked, right? So if you look at chicken walked, and you want the GenAI large language model to be actually able to kind of complete that sentence, right? And obviously across the road is what we want the model to say. And EOS stands for end of sentence. So you actually have to kind of tell the LLM that that's the end of sentence, right? So that's a funny thing because always a lot of people come and tell me, hey, AI is going to take over the world, and don't know what will happen to us, and there's going to be people are not relevant anymore. But in AI, you have to keep telling them everything, right? So I don't know how they'll really take over the world, but anyway, that's a side thing, right? So that particular, if you look at some of these words, and then there you feed that into the architecture. So it gets converted into something called as vectors, right? So if you look at token and position embedding, that embedding is actually like a series of vectors that it kind of put weights on, and it kind of pushes it into the neural network, works through the various permutations and combinations possible, and then based on the complexity of the question asked, like I said, there can be multiple intermediate layers of a transformer architecture, and then it kind of decodes it back, and based on the training material, based on the positional weights, etc., it kind of completes the sentence to say across the road, right? So there's a lot of very complex math underneath it. So if anybody that is interested, just go go into YouTube and then search for some of the transformer architecture and how it actually works. It can be interesting or put you to sleep, right, based on which side of the fence you're on. So I think that's very interesting too. But I think what is very important on this is some of the advances made in transformer architecture, and given that broadly this architecture has not really changed in the past 7 to 8 years. So, most or all of the LLMs still use transformer architecture. Kind of tells you, how important this is for kind of Gen AI. And I think the other key thing, right? And it's a very interesting question because I speak to a lot of people who talk about GPT-4 and things like that, right? So and I ask them, okay, can you tell me what GPT is, right? What would GP and T stand for? So everybody gets generative because that's generative. Most of them get pre-trained. So it's generating data, that's a generative. It's pre-trained, that's what the P stands for. But the T actually stands for transformer, right? So that's the thing that most people don't actually get. That GPT stands for generative, pre-trained, transformer. So transformer is obviously a very core component of the architecture, and the technical kind of baseline on which GPT and everything is built, right? So that's the actual transformer architecture. So in terms of how do we actually use some of these and solve problems, right? So based on what LLM it is, which company, there's OpenAI and everything, Gemini, everything else, right? So it's been obviously pre-trained with a lot of generic data from the web, various sources, large data. So there's a lot of pre-trained that is actually happening. I think what's also interesting here, right? You can I think visualize some of the neural networks I spoke about. So if you look at under pre-training, you can look at the input layer, the various input neurons or nodes. It has one hidden layer, so it's the kind of the least complex one, and then you have 3 output nodes, right? And then the lines that you see between nodes are essentially the weights, right? So that's how you kind of represent the neural networks. But anyway, going back to it, so pre-training, you have generic data that you kind of take and pre-train it. A lot of examples, you need sometimes very, very specific data, right? And specific data is obviously in the form of, for example, if you want to try and solve medical problems, you might have specific medical data that you want to feed in. And based on whatever your specialized tasks, right? So in this example, I've kind of taken a specialized task, saying that if you want to write look at medical reports of somebody, or a combination of medical reports, let's say ECGs, blood tests, combinations of some of these reports, you feed that into like a GPT-4 kind of thing, and you want to kind of essentially say provide like a medical summary, right? So for that, your generic data is not sometimes not sufficient, right? Because what is there in like the open, the generic domain is sometimes not sufficient to solve some of these problems. So the more and more fine tuning you do with your research papers, or feed it like hundreds of medical records and reports based on kind of history of a lot of people, and keep training that. So obviously some of these specialized tasks become easier. So I think that's what you're doing. So you have generic models that you can use for most if you want to answer or solve generic questions, but there's also a lot of fine tuning that you can do specific to your problem, right? And there can be specific sources that are very contextual to you. Okay, let's talk about use case types for generative AI. And if you talk about use case types, I think broadly, this is how I categorize. So in my own mind, at least, I think it's easy to categorize into types based on what the generative AI does. So if you can look at these 4 types, they're typically, I put them as create. So Gen AI has the power to create. The Gen AI has the power to discover certain patterns. It has, what it can also do is it can summarize. And then lastly, it can automate, right? So these are broadly at the umbrella level, I would say, certain categories. there might be other outlier categories, and day by day you're seeing more and more of everybody's pushing the boundaries in terms of what it can do, right? So there's possibly more categories, but broadly, for the purposes of my conversations with when I speak to people in the industry, I think these are generally four agreed categories of use case types, right? So when you talk about create, for example, so if any creative industries, if you're looking at any content development, anything that is required, so all of that falls in this, right? And there's I think there's a lot of very interesting examples, right? So if you look at, and I'm sure many of you have actually seen this or read about it. So a lot of the big Hollywood productions, right, used to, if you look at, Ben-Hur or some of the older ones, or even Gladiator and some of these movies, they used to have like literally like hundreds and thousands of extras, to recreate these huge, battle scenes and things like that, right? So there's a lot of that work has actually been now taken over by AI, right? So a lot of the background, the kind of army, like fight scenes or things like that. There's a lot of that is now replaced by AI and Gen AI specifically, right? So that's how you see some of, and also I think there's been a lot of discussions. Again, if some of you might have heard in terms of so if you are a creator, so if you're an artist who's trying to draw something, and if you are trying to create music, so all these industries are impacted, right? Because you have AI is gradually taking over some of these. It can produce new songs, it can produce some of the best work, drawings, etc., artwork to rival the Picassos of the world. So it's gradually taking over, right? So that's all the creative part of it. So if you come to the discover is obviously trying to discover hidden patterns and things like that. So you're looking at specifically in the data space, if you are trying to look at kind of observations that is not very clear for humans to look at. AI can obviously look at and discover some key patterns and things like that. And if you're trying to solve specific business problems, looking at data that is not very intuitive, again, you can discover a lot of patterns, right? And we'll actually look at real world examples of each of these, right? So we'll continue to do that. So summarize again, because the new ability to comprehend language and generate language. So because of that, in terms of all the unstructured documents, anything that is digitally there, right? Whether it's for example, lawyers, if you they have to look at history of cases to understand the implications for them on the case that they're currently taking, for example. A lot of that, if they need summaries of it, if they need to look for specific keywords, kind of bring paragraphs across a large content base that is relevant to them. I think again that's part of the summarize phase, right? And I also see, for example, in the sustainability space, right? If you look at sustainability, it's a really big thing these days, and sometimes it's very difficult for organizations to keep up with the rules and regulations in that space, for example, because new rules are being kind of written on the spot. So anything regulatory, and even for banking and others, right? So if you want to be able to go through like a lot of content on web, on research papers and elsewhere, and kind of look at specific aspects of what that regulation means to you. Again, that's an important way of using Gen AI to summarize. Lastly, if you wanted to automate some of the tasks, and there's a lot of around legal, again, contractual documents, etc. And actually have if you look at automation, a very interesting use case is I've spoken to a few doctors, right, and they had the conversation in terms of what AI means to them, because ultimately in the health industry, everybody, when they go to doctors, they like an actual person to be there, right? And obviously, when doctors are trying to adopt AI, what they're saying is a lot of their administrative work that they do today, right? So as part of the work, there's diagnosis work where they spend time with patients, etc. But there's a lot of administrative work that they have where they have to fill in reports, they have to look at reports, and that requires fairly deep subject matter knowledge. So some of them have actually started using Gen AI for at least the administrative tasks, right? So maybe I think we're still at least a few years away from going, instead of going to your doctor, just having a consultation with a robot or something that will look at some of your reports. I think that is still I would say 5 to 10 years away. But at least some of the administration back office kind of work is already being done by doctors and others. So it started kind of creeping in, right? So again, I've taken very specific industry examples for these 4 categories. Creation of new content for universities. If you're trying to create new code, you don't have to actually go to various places and snip code and trying to attach them and make sense, right? So there's a lot of if you want to take some of the legacy code that is there, legacy SQL and convert it into Python or whatever, there's a lot of work. It's also being used for that, right? Marketing is again very big. So everything from brochures to written content, etc., as well as game content development. There's some real world implications of Gen AI where it's creating, right? So discover, a lot of the asset maintenance kind of problems where you're trying to predict failure of assets and things like that. So that if you wanted to turn, that's discriminative at this point in time. But I think there are certain implications if you want to turn that into generative and have it engage with say like call centers, or have it engage with certain customers and things like that. I think there's some merit to that, right? A lot of the traditional business intelligence, as you see it, is starting to go away, right? So there's building dashboards. Even if you look at Microsoft, they're pushing very hard on Copilot, right? So the traditional BI as we know it is starting to disappear, right? Where you build like static dashboards and then somebody has to come and interpret what those dashboards actually mean. So it's going to be much more real-time interaction using natural language. So some of that and things like fraud patterns, etc., are again something that is for discover. Summarize, I think we spoke about some of these. Customer support. Customer support is a very interesting example because most of the early implementations of Gen AI that I've seen in the industry is based on customer support, right? So customer support is really one of those that has taken off very early. It seems a fairly safe like proof of concept to do right now. So most proof of concepts and implementations at this point of time are in customer support, where they're trying to look at a lot of unstructured data, audio data, call data, etc., coming in and trying to keep the customer happy. We spoke about health diagnosis. We spoke about legal and research compliance. These are some of how we continue to summarize. And then automation is on the insurance side. If you need like a claims assistant who will take some of that and help you raise claims. Planograms in the retail industry, where based on certain content, you have to generate images of and for planograms for people who are not in the retail industry are when you go into Woolies or Coles, it's you have your various products stocked in a certain way, right? You have, let's say, juices on top, and then you have something else in the middle, and you also have like candy near the eyes where you're checking out. So there's a lot of logic behind it in terms of what kind of products need to be kept where for people to actually go and purchase, right? So Gen AI can also start, in some cases, some organizations already doing it with the kind of generating images of planogram images, etc., based on certain data points, and of course the digitization of content, etc. Right? So look, again, this is not an exhaustive list. I think this is just when you're trying to create like a construct saying these are four types of categories of Gen AI where it can help you, and then some example industry use cases where I've either spoken to somebody about it or heard of it. These are some, but there's no end to this, right? So so you can continue looking at these 4 categories and see if there's something that kind of interests you. So kind of trying to wrap up, right? So what are going to be, what is going to stop this behemoth from marching on rapidly, right? There's quite a few implications. So many customers, right, who kind of caught up in this whole Gen AI frenzy are coming and saying we want to do something in Gen AI, right? And the first question I always ask them is, what about their modern data ecosystem, right? Is that in place? Is that, do you have some place where you're getting reasonably clean data, trusted data, because like most stuff, right? So even Gen AI is garbage in, garbage out, right? So obviously continue to emphasize some of those traditional modern data ecosystem principles. I think that they're not, right? So they continue to be important. As part of that, data governance, I think, again, plays a big role, because there are far-reaching implications of Gen AI, right? Because it's going to be kind of become all pervasive. And I talked through some examples of where where it has kind of breached in terms of irresponsible usage. It's gone into certain gray areas, right? So there's going to be a lot of questioning, right? So there's going to be a lot of focus, everybody's going to be looking at if Gen AI is saying something, why is it actually saying that, right? And you really want to make sure that your fundamentals are in place. Your data is saying what it is saying. It is well governed. You have owners who understand the implications of certain things going out. So all of that remains, right? And I think the other big thing is, again, based on our conversations, is the operationalization of Gen AI. So a lot of in the industry, across industry, like I said, a lot of customers, etc., are in like a POC, proof of concept stage, where they're trying to look at what it means for them. Just because maybe their exec has asked them, saying that we've heard about Gen AI, what can you do for it, right? But I think that they're kind of struggling to embed it back into business process, because a lot of it's called the it's entering the POC valley of death, right? I call it. You go, it can never come out again. So there's a lot of like those kind of things that are happening. I think contact center, like I said, that's one area where it's kind of going into more implementations, etc. Responsible use of AI, right? So I don't know, it's like a story in terms of, I don't know how many of you read. So there, Isaac Asimov is a science fiction author, and he writes this beautiful series of stories based on robots and AI, right? And he built what is called 3 laws of robotics, right? So you should look it up. It's essentially a construct where he tried to put it into like rules. What are robots essentially bound by, right? Can they harm humans? The various level of ethics, right? Can they harm humanity? If there is a conflict where they have to harm a particular human versus conflict of of more people being affected by the humanity, what do they take, right? And there's this whole set of stories that he writes on edge cases, right? So how, because there are these laws of robotics, obviously there are edge cases, and what happens when in those scenarios. So we should definitely take a look at it, right? But I think in a real world example, this, I'm sure you've been following, I think a few months ago, what's been happening with Google Gemini, right? So that was really, really interesting. I think that's an first example of where something has backfired, right, in the Gen AI world. And I think, make no mistake, there's going to be several more examples before AI and Gen AI kind of self-corrects into something that is palatable by the wider ecosystem, right? And people who have not followed it. So for Gen AI and AI in general, right? So there's a couple of things that it needs to be, obviously it needs to be very fair. The AI model, the output of the model needs to be kind of very ethical, fair, and that's what when Google tried to build their image generating tool called Gemini. So they kind of built it, to make sure all those ethical controls were in place, which is absolutely a good thing, right? But what happened is they did not correct for accuracy, and therefore, when people started using that tool, they asked for some searches that were maybe ethically correct but not very truthful, right? So for example, if they are they ask for images of like Vikings and of Vikings in the past, and Gemini gave them obviously Vikings of various races, right? So and though that might make sense from making sure that everybody's we are kind of inclusive, a lot of people said that it's in terms of accuracy, it's untrue, right? Because you could, for example, you could not have had like a brown skin Viking in the past, right? So that's historically inaccurate. So some of these conflicts, then it became kind of politicized, and a lot of they had to actually retract some of that, right? And they had to rework on it. So I think it's always going to be a fine line where you have to make sure that there is a lot of bias. If you look at historical data, there is going to be a lot of bias, right? So, for example, if you didn't correct for bias, an AI would tell you that men probably deserved more salary than women, purely because of the fact that historically that's how it has been biased, right? So you have to correct for such biases to make sure that what is historically your training data has a certain pattern. That's not necessarily how it should work in the future. So you have to continue and correct for such biases, and you need to have controls to make sure that some of these outputs are very fair, and you ensure that historically that might have been the case, but obviously you need to have very similar salaries for both men and women, right? So but while you correct for that, there's always like a thin line you walk in terms of saying when you look at more complex situations, right? How do you correct for accuracy versus bias and things like that? So it's going to be very interesting. It's a very fast evolving kind of world. So there'll be, like I said, a lot more of these kind of arguments, corrections, and it's become very, because Gen AI has become so visible these days. I think it's the everybody is kind of getting into the argument and getting into this fun. So it's going to be like I think a fun and wild ride. So yeah, that's some of the challenges. The technology is improving, but it'll be very interesting. I'm sure all of you will be raring to kind of see how this evolves, right? Yeah, that's pretty much it. There's a lot of go and look at some references, the Turing lectures. There's a lot of work on that some of these bigger organizations have put out in YouTube and other places. So keep kind of looking at Google and other things. It's a very interesting field. But thank you so much for listening in. I hope this was useful. We'll see if there's any questions, and we'll continue to address some of these questions. So I can see a couple of questions. So I think so there's a question on what industry have we seen adopt Gen AI the most? So I think industry-wise, right? I think it's always going to be the financial services that are the early movers on this. So there's a lot of work that financial services organizations are doing in this space. There's in terms of specific areas, I think it's more around the contact center customer area that they're starting off. But I think that's probably the what I'm seeing as the early adopters. And retail and consumer goods is another entrant into the space because there's a lot of visual and they get a lot of unstructured video and image content and things like that. So there's that's what we're seeing in that space. So yeah, that's it. All right. So thank you once again. I can see no further questions, but it's been lovely, talking about this topic. It's obviously a very interesting topic that's continued to evolve. We will send across this recording to everybody on this call. And do continue to engage with if there's any specific questions or thoughts. Continue to engage with us and Altis Consulting while we navigate this new concept. Thank you.